Hi guys, welcome back. It's Professor Hank. In this video, I'm going to give you a quick example of how you can design a C++ program using a couple of different types of tools. So the one tool we'll look at is flowcharts and the other is pseudocode. So we'll look at those side by side, and we'll also look at the C++ code that we'll implement based off of a design using those tools. So let's go ahead and get started. And the first thing that we're going to do is we're going to look at the flowchart. Okay, so believe it or not, there is syntax and semantics for flowcharting. So I am on draw.io in case you are wondering where I'm at. And what you have for flowcharting is a lot of stuff, right? There's a lot of things you can do, but I'll keep it basic for this video and only show us what we need. So when you have flowcharts, okay, what you often have is you'll see, these ovals, right? So ovals are sometimes referred to as terminal symbols, and they are used to indicate when a program begins, right? So they're usually labeled like start or begin, and when they're done, right? So then you can have something that looks like, this, start and end. Okay, so those are the entry points to your program and the exit points of your program. Okay, so then what you have is you'll often see rectangles. Okay, you'll see parallelograms. Okay, this is certainly what our textbook includes, and you'll see diamonds. Okay, so what are all these? Okay, so with the rectangles, what you have is you have some kind of a processing activity, right? Some kind of internal processing. So what do I mean by internal processing? What I mean by that is you have, some kind of operation, like maybe you are adding a couple numbers together, for example, right? Maybe you're, dividing something, whatever. It's an operation like that, right? Where there's no interaction with the user. Okay. So what about parallelograms? Okay. Well, with parallelograms, what you have is you have some kind of operation that is an interaction with the user. So you've got something like the see-in statement or a see-out statement, right? Some way that you're getting input or providing output to the user. Now, what about the diamonds? Okay, well, with the diamonds, what you have is you've got a decision. Okay, that can either be yes, no, true, false. So this is a decision symbol. All right, so you've got that. All right, and then finally, what we'll have is you'll have some kind of an arrow. Okay, and so the arrow is used to display or to control or to indicate the flow from one state to the next, right? From one thing to the next. And you follow the arrows, and that lays out the order in which operations are occurring or which things are transpiring. Okay, so let us say that we wanted to design a program that would, that would square a positive number. Okay, we'll keep it simple, and then I can illustrate all these different ideas, with a simple program. So what you could have is you'd have something like where you'd have to prompt the user, say, right? You'd have to say to the user, enter a number, okay? And so we could do something like prompt user for a number. Okay, so we're going to label it. That's what we're going to do. Okay, and so that's the first thing that our program does. So we're going to connect the start symbol with that prompt. Okay, so once we've prompted the user for a number, then we can, store their response. Okay, so we'll go ahead and we'll put another thing here: store their response. Store response in X. And by the way, these labels, as long as the user or someone who's reading it, I should say, as long as somebody can read your flowchart and understand what's happening, then it's good, right? There's no perfect way of doing this. So I'm gonna make another arrow here because once we prompt the user for a number, then we're gonna store the response in X. Okay, and I want to only work with positive numbers, right? That's what I said before. Okay, so what we're gonna do then is we're gonna test that number. Okay, so we'll have like a little input validation loop here. So I'll put a test here, and we'll say something like, is X less than or equal to 0? Okay, and I'll put a little question mark there to indicate that it is going to be a question. We're going to do a little test. Let's connect the arrow. Okay, so if that's true, if X is less than or equal to 0, well then we want to reject what they gave us. Okay, we want to tell them that this is an error. Okay, so we're going to interact with the user, so we're going to use that parallelogram. So tell user that's an error, okay, and then what we're going to do is we're going to connect that right there, and then we're going to prompt the user and store the response again. So let's get a parallelogram here. We'll say prompt user for the number, okay, and then we got another little arrow here, okay, and then we're going to store their response. Again, this is going to be an interaction with the user because they're going to type a response. Store response in X. Okay. So then let's go ahead and make another arrow here. Okay. Now, from there, what we'll do is we'll make a little label here. We'll say, if this is true. Okay. So we'll say true. Okay. If it's true, then we're going to do that. And then what we have to do is we have to go back and make that test again. Okay. So we're going to draw the arrow going to here. Okay. And I got to try to get this up there so it lines up nice and pretty. Okay. And that's a little off. It's a little broken. Okay, let's try it one more time straight. One more time. Okay, we'll do that, and then we'll do that. Okay, we'll move you up here, and I want this arrow pointing this way. Okay, I should be able to right click on this and delete that waypoint. Okay, there we go. Now it's finally pointing the right way. Okay. Now it's not pointing the right way again. Okay, so we'll point this right there. We'll move this up. And try this. There we go. There we go, got it, perfect, okay. So yeah, so once we store the response in X, then we're going to go back. This is a loop, right? We're going to go back and we're going to test X again. Okay, and if it's not less than or equal to 0 in this case, if it's positive, then we're going to go right on past, right? So here we'll say something like, we'll have an internal operation that's going to happen. Okay, so what's that internal operation? We're going to square that number. Okay, so we'll do something like set X to X squared. Okay, so we'll do that. And then I want to show you an if statement, so an example of that. So I'll just do something really silly here. I'll do something like a little test here that says, if X is greater than 100, if X is greater than 100, then we'll do something really crazy. We'll print out, oh, that's a big number, right? Or that's what we'll do. If that's true, then we'll print out to the screen, X is a big number. Print X is big, something like that. Right, if that's true. Otherwise, we'll print out something else. We'll print out X is small. Now let's make a little true here to indicate that that's what happens if it's true. And I should put false over here, right? Because If it's false, then there's only two options. It's either true or it's false. Okay, so if it's false, we're going to go down here and set x to x squared, and then if x is greater than 100, we'll print out, if that's true, we'll print out x is big. Otherwise, if it's false, then we'll print out print x is small, right, something like that. Okay, we'll do that, and then we'll draw our arrow down here. Okay, and then we'll put false to indicate that this is false. Okay, so there we go. And then regardless, what we'll do is we'll say goodbye, right? Then we'll print goodbye. Print goodbye. Okay, so no matter what happens, whether, let's see here, whether x is greater than 100 or whether x is 100 or less, we're going to print goodbye. Okay, and then after that, the program is done. Okay, and then we'll write this up in pseudocode here so you can see that too. Okay, so there we go. So if you look at this now, we can follow the logic of our program. We have a plan. Right? Our program starts, we prompt the user for a number, we store the response in a variable x. If x is less than or equal to 0, then we tell them that's an error. We prompt them for the number again. They type a response. If they type, and then we go back and test it, right? So let's say that they type 10 this time. Well, 10 is not less than or equal to 0, so that's false. So then we set x to x squared. And 10 squared is going to be 100. So is x greater than 100? No, that's false. So then we go down here and we print x is small. And then we print goodbye, and then the program's over, right? Now, if the user had, instead typed, maybe, I don't know, 20 squared would be what, 400. So in that case, this would be true. We'd print x is big, then we'd print goodbye, and then the program's over. So you can see that we've got now a plan. Okay, that is an example of using a flowchart. So we've got our terminal symbols, we've got our interaction symbols, we've got our decision symbols, we've got our processing symbols. Okay, so those symbols mean something because it makes it easy at a glance to see what's kind of happening, right? So even if I didn't put any labels, you'd know that you started, that you had some user interaction, you'd know you had a decision, and then some more user interaction. Then down here you would know that there was some kind of internal processing going on, then another decision, and etc. Right? So the symbols matter. They absolutely positively matter. So let's write up a pseudocode version of this. Okay, so you can say, well, I mean, what's pseudocode, right? You can say that it's just plain language, right? Maybe a combination of English and programming symbols, whatever. There's no standard for pseudocode. It's not like you compile it or there's some book that you read and say, here's the only way you can write pseudocode. Here's the standards version of pseudocode. No, it's another one of those situations where if the reader can understand it, then it's probably good. Okay, so for example, I could write something that looks, maybe like this, where I could say, start program, okay, and then I could do something like prompt the user for a number, okay, and let's make this left justified, so that way it's easier to read, okay. Okay, let's make it left, where are you, text, there you go, left justified, there we go. Okay, so step 1 in our algorithm, the program starts. Step 2, prompt the user for a number. Step 3, store response in X, okay. And then you can say something like, step 4, while X is less than or equal to 0, then we're going to do something, right? So what are we going to do? We're going to do something like this. We'll say, tell the user there is an error, right? And then prompt the user for a number, right? And then store response in X. Right? And then Sometimes people will put in like 8, or they'll put in something like end while or something like that, just so it's easier to see. But fine, some people put that in, some people put that out. It doesn't matter. As long as the user, or excuse me, whoever is reading this can understand what you mean, then it's good. Okay, so as soon as x is not less than or equal to 0, then what do? Right? We set x to x squared. Okay, that was the next thing we did. And then what? Then we checked if x is greater than 100, then what? Okay, then we print x is big. Okay, else, right, because it was an if else, we print x is small. Let's see if I can move this here so I can get all on one screen for you so you can see it side by side. Else, we're going to do what? We're going to print x is small. All right. And then, no matter what, we're going to print goodbye. Okay, so there's our pseudocode algorithm for the program that we're going to write. So let's go ahead and write that program. I'll bring up Visual Studio and we'll see what that looks like. We'll convert our design into C++ code. Okay, so let me go ahead and write a C++ program that implements this. And I'll just put it over here instead of doing, I won't go through the whole thing of putting together Visual Studio. Okay, so let's go ahead and see what some C++ code could look like to implement this program. Okay, so a C++ program to do this, we would include IOStream, so that way we'd have access to C in and C out using namespace std. All right, then we've got int main. Okay, and then let's move this down here so it's closer, and I will move this over here so you can see it, hopefully. Okay. All right, so what was the first thing we needed, right? We needed to prompt the user for a number. So cout, enter a number, right? And then what was the next thing? Store the response in x. So I'll store it in x. That means I'm gonna have to define x. Okay, and I'll support floating point numbers, why not? And then I gotta check my x. I got my input validation loop, right? So while x is less than or equal to 0, we have to do some things, right? We have to tell the user there is an error. We have to prompt the user for a number, and then we have to store the response in x. So take a look at the flowchart. Same dealio, right? So tell the user there's an error, prompt the user, and then store the response in x. So either way, right? So let's do it. So cout error, and then cout enter a number, and then cin x. Okay, so that covers, now our while loop is covered. Okay, now once the user actually types in some valid input, then we can move past that while loop, and then we are going to set x to x squared, so we can do something like x equals x times x, right? And then we got our if statement. If x is greater than 100, we're going to do what? We're going to cout x is big, right? And then otherwise, cout x is small. Okay. Yeah, and then finally, what we're going to have is we're going to have goodbye. Okay, so cout goodbye. Okay, and then in main you always want to have, or you usually want to have a return statement, right? So let's throw it in there. And let me indent that just a little bit more so you can see it a little bit better. Okay, so yeah, there you go. So you've got your program, right? We went over flowcharting, and we designed a program. that will square positive numbers. So, we've got our terminal symbol. That's how we know where we're going to start. You follow the arrows, prompt the user for a number, and then we store the response. We have our loop, checking if x is less or equal to 0. If it is, tell the user that's an error, prompt the user, store the response. Right, so what do we have? Prompt the user for a number, store the response. If the number is less or equal to 0, tell them there's an error, to ask them for the next number or for a number, store it in x. Okay, and as soon as they give us a number that's good, say 22 or say 20, well, then this test is going to be false, and then we fall through to set x to x squared, which we did here, x equals x squared. And then from there, we have our test condition. Right? If x is greater than 100. If x is greater than 100, which 20 squared would be, right? That'd be 400, right? So if that's true, then you print x is big. Print x is big, print x is big. And then you skip the else, right? You skip the else, you skip the else, and you go right to goodbye. So then we print a goodbye. And then we're done. That's it. So as you can see, both these tools, they're very good, right? They're very good for helping you to think through what it is that you're trying to do. Okay, but it's not just for planning either. It's also for helping you to understand complex code that maybe you didn't write. So you can diagram out code using pseudocode or using flowcharts. I'll do that sometimes just to demonstrate to students how complex programs can get. You'd be amazed at how complicated even a simple little homework assignment can be, where you wrote like 20 lines of code, and you can end up with this flowchart diagram going all over the place. And if you can hand trace, and because you can hand trace, you can diagram the code, you can really get a feel or understanding of what's actually happening. Hand tracing to understand what's going on in memory, and then flowcharting to be able to see a visual representation of your code. So, or of the code that you're examining. And then, of course, the use for them as a design tool is fantastic, right? But especially with pseudocode, because with pseudocode, you can just write in whatever language you want. You don't have to remember symbols, you don't have to remember anything like that. And you just write it so that it's understandable, right? So that way you can get the logic straight in your head. And it's fantastic for that. And yeah, so there you go. That's going to bring this video to a close. As usual, if you're a student of mine and you have any questions, then feel free to email me. Stop by my office hours or hit me up on Zoom. For everybody else, if you thought the video was useful, please consider giving it a thumbs up. If you thought the video sucked, you got that thumbs down as well. Consider supporting the channel in different ways. Subscribe, leave a comment, hit the bell so that way you'll know when new videos are released. You can join as a member with additional perks for as little as 99 cents a month. And of course, you got that super thanks there as well. If I helped you with your homework, if I got you stuck, or got you unstuck, helped you get through a tough spot, please consider, hitting that super thanks, tip your teacher. And the proceeds are going towards supporting the channel. Okay. All right. That's everything I got for you. We'll see you next time.